to have Reto with us. As you all know, detecting SQL injection is more than just looking for a single quote, and I think you did lots of research about what is more than just a single quote. How can I find it? So, yeah, thanks for being with us. Good luck.
So, thank you very much. The topic is an alternative approach for real-life SQL injection detection. My name is Reto Ishii. I'm from Switzerland. I'm the lead security engineer and the developer of the web application firewall Airlock. The content of this presentation is SQL injection is not yet boring. Then I will say something regarding false positive for real-life SQL injection detection. Then we will present you one of the classical approach to filter SQL injection. And the main part will be lib injection, which is a library for SQL detection through lexical analysis. Who of you already heard of lib injection? Okay, so I will recap the concept. So at the end I will show you a new approach based on lexical analysis to reduce false positives. And when we have enough time, I'll show you a short prototype demo. So SQL injection is not yet boring, as you can see on these pictures. People are very creative where you could use SQL injection, for example, to compromise road pricing systems. Nevertheless, also for web application, it's still one of the major threats, as you are already seen on the previous presentation. So in OWASP top 10, it belongs to the first or the category with the highest risk injection. And yeah, almost in any statistics you find in the internet, it has most of almost the highest risk rate. So coming to real-life SQL injection detection. So is SQL injection blocking hard? Definitely not. It's very easy. You can block everything, then you blocked all SQL injection. So it's quite obvious that you can't use such an approach. Your application is no longer accessible. Nevertheless, when you want to do it a bit better, say, let's block all terms, all symbols, and so on. Even this can sometimes be circumvented. There are a lot of obfuscation techniques like different encodings you can use, multiple encodings, and so on. When you are interested in these obfuscation techniques, I can recommend the presentation from Roberto Saldago a few weeks ago at Black Hat, USA. So classical good blacklist rules tend to be very complex because they have to consider false positive, what we will see in the next slides. So unfortunately, this is an unsolvable decision problem. So you can't decide correctly in all cases whether it is SQL injection or not when you don't have additional information. What's usually the case for web application firewalls. So additional information means you don't know the statement, you don't know where the injection can appear, maybe you even don't know which database management system the application is using. So when you have very strict rules, which is quite easy to create strict rules, then you need an extensive exception handling. And based on this exception handling, it's possible that your overall security of the application is even worse than when you have less strict rules, because most of the arguments are maybe whitelisted. So consider, for example, this example here, easy select statement where you could inject here into the password field in a single quote context. All these 10 variants can be used to bypass this password check. So do you really want to block all these strings here? So maybe you say, okay, yeah, let's block it. Let's block a quote, operator quote. You can do that. Maybe you end up in a lot of false positives. When it comes to a non-quoted context, like here when you compare an integer, then it's even worse. So you can no longer search for any quotes. So basically when you want to block that, you have to block the word or yeah, the symbol. So the classical approach to filter SQL injection, that's basically what we do actually. So we have moderate complex regular expression. We categorize these expressions according to the attack types, and in these several categories we consider different database management systems. For example, how do the command symbol look like in these databases and so on. One example, extending the query result with a union select. So again, the red part is the injection. An obvious trivial filter would be you block select. Unfortunately, this causes a lot of false positive. So now you have to add additional conditions. That's very dangerous. Maybe an attacker find a way to use this condition to circumvent the filter. Nevertheless, as you see, the expression gets much more complicated, and even this one can be circumvented. For example, with different code spaces which are not matched by \s, this PCRE. So let's recap libinjection. Libinjection is a library for SQL injection detection through lexical analysis. It is available in C++ and Python implementation. It's on GitHub, it's open source. The author is Nick Galbraith, and we have seen him, or the library, 2012, first time at Black Hat USA. So libinjection considers 3 different contexts where injection could happen. In the first context, you don't have any quotes around your injection string on the application side. In the second context, you have single quotes, and in the third context, you have double quotes on the web application side. So it's a lexical analysis parser, so it basically creates a token representation of your input strings. That's an older version of libinjection. That's the set of tokens which was used there. So you have keywords, logical operators, numbers, functions, braces, and so on. So now, how does the tokenizer work? Basically, you have 3 times here the same injection. And depending on the context where this injection happens, you have now a completely different representation of this token string. So in the first example, everything up to admin is a string, admin is a name, and then again we have the start of a string. So here you terminate the quote on the application side. So everything, or the string starts with union, which is a special key. Then you have select, which is a standard key, star is operator, and so on. And in the third context, you don't have any double quotes in your injection string, so everything is a string. So libinjection has some nice features. For example, it folds numbers, so independent of the representation of a number, it ends up in the token 1. Strings with quotes around it are folded to the token S. Simple arithmetic expressions are folded to the representation or to the token 1. So they are not evaluated, they are only folded. And comments are removed and so on. There are a lot of features in this parser. So how does now the decision work whether user input is SQL injection or not? Libinjection has a set of fingerprints, and these fingerprints have a length up to 5. And that's a quite interesting thing. So libinjection compares only the first 5 tokens of your input strings. And according to Nick, that's enough to decide whether it's SQL injection or not. If this is true, if this is secure, that's really cool, because that's unbelievable fast. You only have to parse the first 5 tokens, and you have a quite small list of fingerprints which you can sort, binary search, and so on. So this fingerprint list is, as I heard, basically learned or generated from a large list of SQL injection pattern. So coming to the weaknesses of libinjection. So basically, that's my personal opinion here. I know there are already a few web application firewalls using this library. So one problem with libinjection, I thought, is this 5 token limitation. Can it be bypassed? And yes, it can. So for example, you add some padding string like this one here, 1 XOR 1 XOR 1, and so on. And with this padding string, you can basically hide your real attack. And the real attack in this case here is the command symbol. So it could also be a semicolon where you start a new command, and so on. There is also injection possible when you are in a quoted context where you, for example, can use the concatenation symbol to circumvent your attack. So on Monday I sent this presentation to Nick and said on these slides there are a few issues. And on Wednesday he gave me feedback and said everything is solved. You took a look at the old version, the newest one is fine regarding this. So I took a look at the newest version, and he increased the number of fingerprints from 2,000 to 9,000. And now he faults these operators here. So the whole XOR 1 and so on is folded to the token 1. And with this, he fixed this problem. So, but basically, I think that's more of a conceptual problem. Is it really possible to fold and whitelist all possible combination such that this padding attack is no longer possible? So that was on Wednesday. So in the plane from Zurich to Hamburg, I wrote a small fuzzer. And that's basically this one here in Python. It has a list of tokens, and it creates all possible combination up to the length 5, so basically cross product of this list. And then I whitelist all the token combination which make no sense, for example, two consecutive operators and so on. That's not possible in SQL injection. So I stripped them out. Then I checked whether it's, or I generated a SQL statement with these token representations. And I checked with MySQL whether it is valid SQL. And at the end checked whether live injection blocks. And that was the result here. So it takes 15 seconds, I think. So with all these strings, you can now pad your attack. So you can basically, you see here the command symbol at the end. That would be one possible attack to remove certain conditions. But you can also start a new command, maybe doing a union select after this padding. So we have over 350 combinations how to circumvent this filter. I will send this list to Nick, and I think he will add all these tokens. But I'm not sure if you can really fold or block everything without increasing the false positive rate significantly. So one other problem with lexical analysis you have is you reduce the scope to a smaller domain. So basically you generate such a token representation, and it's possible that the false positive can end up in the same token representation at the end. So, but this can be quite easily fixed. So, for example, you don't have to consider select and from in the same way. You can say one token is a bit special. It's a starting token. The other maybe depend on it on the first token, and so on. So you add new tokens, and with this you can basically reduce the false positive. I think Nick already did such optimizations to reduce false positives. So live injection is a really cool approach to detect SQL injection, but basically we thought that for us it's not the right approach regarding this fingerprint list. So the parser is cool, we can reuse it, but we really replaced the fingerprint list with the classical approach, meaning making pattern detection. So what we do is now we tokenize the full string, and we make some pattern matching on this string. So now you can no longer evade the filter by padding because we search in the whole tokenized representation. And what we also don't want to do, we don't want to generate the fingerprint list or a list. We want to use human brain power as we did before. So we want to think of how does a SQL injection look like, what's the structure, and so on. So we don't want to generate these blacklist rules. So maybe you can think of, is this more expensive regarding computational effort? Yes, it's definitely. So you have to tokenize the full string now. You can do this lookup. But one benefit you get from this, which has also a huge influence to the performance, and that's you get much simpler regular expressions. So for example, there are dozens of variants how you can separate terms between each other. So we can use tabs, spaces, carriage return, and so on. Even null bytes can be sometimes used to separate tokens. That's quite crazy. And you consider all these in your parser, and has you no longer have to consider it in your regular expression. So one other benefit you get regarding simple patterns is that you don't have these long disjunction chains saying is it select, is it update, is it insert. So basically everything is a keyword or a starting keyword. Yeah. So one example here, you have this classical regex, and the token representation gets much shorter and simpler. So we tested this new approach and we found out that the detection rate was better than our current regular expression, but unfortunately we had more false positives. So we thought, how could we reduce the false positives? And this is now a new approach. So we think of which token combination are not common in SQL. So for example, two names consecutive one, or a number followed by a name, or two numbers, two operators, sorry. There are a lot more examples. So why, for example, are two consecutive names not common in SQL? So when you have such a update statement, you see when you detect or when you parse all the keywords, you no longer have two consecutive black names here. You also, the parser also considers strings, it considers comments, everything regarding this helps you, that this approach is possible. So one example, here you are in a single quote context, you have the example dancing like a robot on fire. So dancing is a string because it ends with a quote, and like is an operator, and followed by two consecutive names. And now you know that's not SQL injection because that's not possible in a valid query. So unfortunately, you have to implement some whitelisting step. There are a few exceptions regarding this consecutive name example. There are maybe no exception regarding consecutive operators and so on. For example, when you have column or table aliases without the as keyword in it, which most database management systems support, then you have to whitelist and consider this in your or you have to define an exception and consider this in your whitelist. So here are two examples. Select IDI. I is an alias of ID and without the as keyword. But there are not that many exceptions I think you have to define. So what's the benefit of this approach? Basically you have now simple regular expression to block your input strings when it's SQL injection. So simple means also there could be quite aggressive, quite strong. And now you have also simple regex to whitelist the false positives. So one thing we have, you may ask, is can we somehow evade this filter with, or use this whitelisting step to evade the filter? And actually, I haven't found any way to do that. Maybe you have an idea, then you can send me. So this is the overall process. I don't want to go through it. I don't have the time. You can check it offline if you want. So coming to the prototype demo. So it's not a big thing. Basically everything is based on lib injection. So as I said, you have a blacklist. Say, for example, I want to block all strings, followed by any character, followed by a logical operator. So take one example here from the presentation. Close it. Okay, sorry. Don't know why it isn't working. Strange. Okay. I hope it's the whole string. Yeah, you see it is blocked. You have here a string followed by a logical operator. Now I can define my whitelist regular expression. So say two consecutive names should not be blocked. Here you have to consider these special exceptions regarding whether you are in a from and select and from statement or update and from and so on. So again, now you see it's not blocked. So you see these three contexts. In the as-is context, that's the token representation where it would be blocked. This is this single quote context, and that's the double quote context. And in this context where the string would be blocked, it's now whitelisted because it's not valid SQL injection. So what are the conclusion? Real-life SQL injection without additional information is really hard. And you want to get rid of false positives. False positives are a pain. Security experts often tend to only take a look at the detection rate, at true positives, not really false positives. And as I said, it's completely useless filter which block too much. So lexical analysis can be used to blacklist, to simplify blacklist rules, can also be used to reduce false positives, as you have seen, and it's definitely worth of further research. So maybe you can think of other code injection attacks where lexical analysis may be sensible, then let me know. So I want to say thanks to Erwin Huber, which makes this project basically possible, and to Thomas Lohmüller for his support. And yeah, if you have any feedback, suggestions, welcome, send me a mail, visit our homepage. So basically we are not marketing guys, so the homepage doesn't look that nice, but yeah, you find the information you want. Thank you.
Thanks a lot, Peter. Are there any questions? Okay, you've been like at the very same second.
Hi, hello.
Hi.
My question is, do you have some testing page, like lib injection has a good testing page, where anybody can try it out? This all looks to me like it's not in that phase like it's lib injection.
That's correct. It's basically a research project. So I have implemented this prototype, as you see before. It's a command line tool. Yeah, basically it's possible to extend this or to create a web page. But what I want to present you is a new approach how you could do that. It's not a fixed implementation. So we haven't yet decided whether we make an open source project or implement it in our WAF. So yeah, the value of this presentation should be the concept and not the current concrete.
It's not fair to the NIC if you don't have the testing page where everybody can get his hands dirty.
Yeah.
And in your case, it's like lib injection is not okay. We are doing the better approach. So it will be fair toward the NIC to have the testing page where we could try it out.
Yeah, that's correct. When you have a testing page, when you really consider both, also false positive, when you have a testing page considering only true positive, that's easy. I can set up one in a few minutes where everything is blocked, as I said. But yeah, you're right. When you test both, that would make sense. So, but as I said, that's or what I want to present you is the concept here, and I don't have a tool yet. So it's not this at the moment. It's not decided how we want to proceed with this approach.
You told that it will be easy to create the whitelist. So do you think that something like good whitelist which could cover mostly everything should be a result of this research?
So basically it's not easy to set up a whitelist, or yeah, it is maybe easy to set up a whitelist, but as I said, it's easy to make blacklists which blocks everything. So regarding whitelisting, yeah, the whitelisting may be good, they may be very application specific, but unfortunately certain fields you cannot really whitelist because all the possible characters you use in a SQL injection must be whitelisted. For example, when you search field or things like that, there are a lot of form fields where you need that open whitelist. So whitelist is not only always the right approach to block SQL injection. or it's not always possible.
Any other questions? Nobody? Okay, well, thanks, Reto. Thanks a lot.